Hello, good afternoon, ma'am.
Hello, good afternoon.
Yes, welcome, ma'am. All participants, you all are welcome for fourth day session of LaTex workshop. Now, I request Nandre sir to introduce our guest and then we will start the session. Nandre sir, over to you.
Yes, ma'am. Thank you, ma'am. Uh, it's my pleasure to introduce our today's eminent personality, Firuza Karmali. She is working as a project manager at the Computer Science and Engineering Department, IIT Bombay since 2011. She obtained her Masters in Information Technology from DG Ruparel College, Mumbai, affiliated with the University of Mumbai in 2010. She has so far authored 8 books, a short introduction to LaTeX, cheat sheet for LaTeX, HTML5 for beginners, computer concepts, and programming in C, etc. All her books have been well received amongst teachers as well as students for their simple and lucid examples. She has a keen interest in programming, documentation, proofreading, and editing, etc. Thank you, ma'am. On behalf of M.E.S College of Engineering, I welcome you for today's session. Hand over to you, ma'am. Thank you.
Hello, good afternoon, everybody. I guess the session is starting at 3, right? So, should I wait for some participants to join or?
No, ma'am, we will start.
Okay.
Participants will keep on joining.
Okay. Sure. Okay. So, I'll just start maybe in another 2-3 minutes.
Yes, ma'am.
Thank you. Next.
Is it shared?
Hello, am I audible?
Yes, ma'am.
And is the screen shared? Okay. So good afternoon, everybody, and welcome to this workshop on LaTex. So I'm Firuza Karmali, and I will be going through figures, sub-figures, creating index, creating presentations using a document class called Beamer, and finally the TIKZ package, which allows us to draw diagrams and much more. So let's start with images. So most of our documents have images. I believe in this workshop, I guess by Dr. Chaya, you might have already got an introduction of how to insert an image. So I'll not waste too much time on the basics. I'll briefly just recapitulate how to insert an image, and then we'll go and on advanced topics like cropping, adding borders. So I'll switch to Text Studio. This is where I write my LaTeX code. And first, let me save this file. Saving this file as 1.tx. Click save. I'll also show you, just a second. So I have saved this file 1.tech in this particular folder. In this folder, I have another folder called images, which has 3 images: LCD, RGB LED, and slide underscore switch. All are PNG files. So let me just add one of them. So we start by adding the document class, which is article. Then we have slash begin document and slash end document. Let's just compile this. So yes, we do have the content written over here. Now to insert an image into our document, we use a package called GraphicX. So let's include that. So I'll say use package GraphicX. And now let's insert the image. So the command to insert an image is slash include graphics and then the file name. So my file is currently located in a folder called images. So the images folder slash and then finally the file name dot png. Let's build and run it. Okay, LED isn't found. I guess it's LCD, sorry. Let me just confirm it. Yes, it's LCD. Let's build and run it. So now we have an image over here in our document. However, there is something wrong with this because we can't see the entire image. So can anybody help me how to resolve this problem?
Ma'am, we need to scale it.
Okay. Yes, scaling is an option. Is there any other way we can do it? Anyone else? Okay, so let me just first write scale. So scale is currently 1, which is the factor 1. So we want to reduce it. So let's say we reduce by half. So that's where we write scale is equal to 0.5. And then when we build it, we do get the entire image. However, the margins aren't properly set. So another way of doing it is by writing width and height, width or height rather. So instead of scale, I can write width is equal to 4 inches. IN is the units, which is inch. Let's build and run. So now we have our image, which is having width of 4 inches. You can even specify, instead of width, you can specify height. However, one must not specify width and height both, so that the proportion, if you write both, the proportion of the image will never be maintained. So the image will be distorted and it will look horrible. So either you go by width or by height, or you specify the scale factor as mentioned by one of our colleagues. Now let's rotate the image. So I'll just keep this as is, and we want to rotate it by say an angle of 60 degrees. So we would write angle is equal to 60. Now let's build and run it. So we do have an image which is rotated by 60 degrees. Well, now let's just copy this image again and paste it, and we'll remove the angle so that we can just see it as is. Okay, let's build and run it. Now sometimes you may want to remove some unwanted outer areas from an image. So you don't need to modify the actual image. You can just include the image in LaTeX, and then using the arguments, you can modify the image in LaTeX itself. The original image file will not be modified. Only the one which is rendered in LaTeX will be modified. So for this, we need to set the clip argument to true. So we put a comma and we say clip is equal to true, followed by the trim argument. Now trim argument takes 4 values for trimming the image in the order left, bottom, right and top. So let's write some values. So let's say we want to trim the image by say 25 mm from the left. From bottom, let's say we want to trim by 35 mm. Then without a comma, sorry. Then from the right, say by 45 mm. And from top, say 20 mm. So let's now build and run it. So as you can see, the image has been cropped. The original image has not changed. As you can see over here, the image which is displayed here is fine. It's rotated by 60 degrees. However, this image is cropped. So it's cropped by 25 mm, 35 mm, 45 mm and 20 mm. So this is how one crops an image. Even the original image has not changed, so you can use the image multiple times in a document without affecting the cropped image. Now let's add a border around this image. So how would you add a border? You would write slash fbox, open curly brace, followed by the include graphics command, the entire command, and then we close the curly brace. Let's build and run it. So now we have an image with a border. However, the border is quite thin. So let's make it thick. So to increase the thickness of the border, we write slash set length. In the first curly brace, we write slash fbox rule. And in the next curly brace, we would write the thickness in points, that is in pt. So let's say we write 4 pt. And now the thickness of the border is of 4 points. We can decrease it. Let's say we make it 2. So now the thickness of the border is 2 points. Also notice that the border thicken. Okay, let's add a border here as well. So we'll write fbox, open curly brace, and then close curly brace after the include graphics command, and let's build and run it. Let's add some space to it. So I'll add a space using the vspace command. Okay. So now if you notice, the second image has a border of 2 points, whereas the first image is having the original border that we had. Let's increase to 4 points. Notice that the thickness is only changing for the second one. Let's add one more image. So I'll just copy this and I'll paste it here. Let's build and run. Okay, so the border has increased, the border thickness has increased for the second and third, but not for the first. That's because the set length fbox rule command has been written after the first image. So if you want your images to have a border of a particular thickness throughout the document, it's best advised to write this particular command just after the begin document command. However, if you want different images in your document to have different border thickness, then you can write wherever the image appears. So now let's build and run it. Well, so now all the images have thickness of 4 points. Now let's say for this particular image, or for all images as we have seen till now, we want to add a spacing in between the border and the image. So that can be written by the commands slash set length, and in the first curly brace goes fbox set and then the space. So let's say the space is 15 points. Let's build and run it. Now if you see, the image and the border has a space of 15 points. Let's increase to say 45 just to be more clear. You see, now there is a lot of spacing in between the border and the image. Let's decrease to 5 points so that it looks better. Okay, now we have something called as the figure environment. Figure environment is used for positioning the figures and specifying a caption. So instead of having LCD everywhere, let's just include different figures. So I'll write the file name, which is RGB_LED and slide switch. RGB_LED.png. Let's remove the angle of 60 points. And this one is LCD, and then this one is slide switch. Let's build and run it. Okay, so we have 3 images, RGB LED, the LCD.png, and then finally slide switch _.png. So remove this vspace command as well. Alright, so we have 3 images. Now let's say we'll add a figure environment to all these 3 images. So we'll write slash begin figure, and then after the include graphics command, we end our figure environment. So slash end figure. Let's do it only for the first image as of now. Let's add a caption to the image. So we write slash caption and we'll say RGB LED. Let's build and run it. So now if you see, we have a caption. There's a caption number, figure 1, and then the caption called RGB LED. Let's do the same for all the figures. So slash begin figure followed by slash end figure having a caption LCD. Again over here slash begin figure and then slash end figure followed by the caption slide switch. Let's build and run it. So we have figure 1 RGB LED, figure 2 LCD, and figure 3, slide switch. So all of these figures have a number. Let's say tomorrow we decide that we want slide switch to come first. So what do? We just cut this figure from here and we paste it here, and we build and run it again. And now the slide switch has become 1, followed by figure 2 RGB LED, followed by figure 3 LCD. If you see, even the numbers have changed automatically. Now you might have used the table of contents command, wherein if you add sections, subsections, all of these appear in table of contents. Similarly, we have list of figures, so that whatever figures that we include in our document, all of them appear in a similar fashion to table of contents. So let's write slash list of figures. Let's build and run it. So now if you see, we have list of figures, slide switch, RGB LED and LCD along with the page numbers. Okay, before we proceed over here as to why list of figures is appearing below this figure number 1, let's just do one thing. We'll just add a page break over here such that the list of figures appears on the next page. I mean, this slide switch appears on the next page. So slash page break. So our first page has list of figures followed by the 3 images. Now let's add some random content. Okay, so I'll just go to Wikipedia. Let's say Arduino Wikipedia. And let's say maybe I'll add a particular paragraph. I'll add 2 paragraphs. Control C. I'll go to Text Studio. So I'll tell you what the behavior that we would like. We want that there should be a paragraph before this image and there should be a paragraph after this image. So let's take a smaller paragraph. I'll just take this paragraph and I'll paste it 2 times. So I come here and I paste the paragraph, and finally after the slide switch I paste the paragraph again. Well, now let's build and run it. So if you observe, let's increase it. So if you observe, both these paragraphs have appeared after the image. However, we would like the first paragraph, then the image, and then the second paragraph. So we can position it by writing the position argument in box bracket. By default, any image in LaTex, if the position is not specified, it appears at the top of the page. So, which is nothing but T. So now if I just build and run it, there wouldn't be any change. Let's say we want the figure to appear at the bottom of the page. So instead of T, we would write B. Let's build and run it. Let's decrease some text from here, or let's decrease the image width to 2 inches so that it fits properly. Yeah. So what has happened is the text has appeared and then the image has appeared on the next page. Now let's say, sorry, I shouldn't have increased here. It should be here. So if you see the text and then finally the image appears at the bottom of the page. Well, but we would like that the image should appear in between these 2 paragraphs, in between the first and the second paragraph. So instead of B, you would write H, which is telling LaTeX that place the figure here. H stands for here. Now let's build and run it. So now if you see, paragraph number 1 followed by the image and paragraph number 2. The image doesn't appear at the center. So let's just style it by adding the centering command. So now we have an image over here in the center in between these two paragraphs. Also, we saw how to insert list of figures into our document. So let's say we have more figures later in our document. These will keep on adding up in the list of figures. So till now what we have seen are independent images. There are cases when you would want sub figures, like one figure and 3 sub figures into it or 2 sub figures into it. So let's see how to do that. So for that we would need two packages, caption and sub caption. So / use package caption and the other package as sub caption. I just hope I'm audible and everybody is with me.
Yes, ma'am.
Thank you. So what we would do, let's just add a page break and we would add / begin figure as usual. Let's say we want all our figures to be in center and the main figure caption should be Arduino, because this is an Arduino circuit. So let's say Arduino. And now we want 3 sub figures, or let's say to begin with 2 sub figures. So we would write / begin sub figure followed by some content which will be a figure later on, and then followed by end sub figure. Now we will have to write how much width your sub figure should occupy. So we could write it in inches, we could write it in centimeters. However, we would want that the sub figure takes up equal amount of space. So what we would do is we want 2 sub figures. So each sub figure should occupy equal space, which is half of the text width. So one figure would be half of the text width is nothing but starting from here and ending till here. So we want the first sub figure to be occupying this space and the second figure to be occupying the remaining space. So how do we do that? By writing 50%. So instead of 50%, let's say we write 45%. So 45% is denoted by 0.45 of the text width. So 0.45 / text width. So this sub figure will occupy 0.45 of the text width. Similarly, I will add another sub figure over here having width of 0.45 the text width. So basically it total comes to 0.9, which is 90% of the entire text width. Now over here, let's add a caption. So let's say we add a caption here first. So / caption. And then this one is LCD. And then over here we add another caption. Let's say RGB LED. RGB LED.png, and we should specify the images folder. This is also an images folder, right? And now let's specify the image itself. So we would take include graphics command. I'll just copy paste this over here. Let's remove the trimming part completely. Okay, now what should be the width? Since we have already specified the width of the sub figure in a percentage, that is 0.45 of the text width, it doesn't make any sense in writing width over here in inches. So we would say that this particular image should occupy the width of this entire subfigure. The width of the entire subfigure is the text width. In our example here it is 0.45, but of this subfigure it is of slash text width. Now let's just copy paste this command over here from here, and we will paste it here as well. And we will change the name to RGB underscore LED dot png. Sorry, the caption need not be images and RGB LED. It should be just RGB LED, and this should be just LCD. Alright, now let's build and run it. Let's just increase it to see what has happened. So if you see, we have now figure number 4 Arduino with two subfigures, A LCD and B RGB LED. Let's say tomorrow we want to add another subfigure. So how would we do that? We would just take this entire subfigure, copy it. I shall paste it here. Just indent it for better readability. And instead of RGB LED, let's change it to slide switch. So slide underscore switch dot png. Let's change the caption as well to slide switch. Let's build and run it. So now what do you see? We see that there are three subfigures under this figure 4: LCD, RGB LED and slide switch. But we want all of these images, all of these subfigures to appear on the same line, basically just next to each other. But why the third, that is the third subfigure C, appearing on the next, below these two images? Can anybody tell me what changes I should be doing here?
Ma'am, proportion of that text means that 0.45 that we need to change here.
Yes, exactly. Excellent. So this is what we need to do. So because 0.45 text width and the second subfigure also occupies 0.45 text width, the third figure doesn't have any space. So hence we need to modify this proportion. So let's say we divide 100 by 3, so that comes to 33%. So we would write slash 0.3 0.3 and over here slash, just 0.3. Now let's build and run it. So now we do have the image all next to each other. So figure A LCD, figure B RGB LED, figure C slide switch under this figure 4. Okay, now let's just do one thing to make the code little bit more readable. I'll just add a space, just an enter over here. So I'll just put an enter here. Begin subfigure, include graphics caption, end figure enter, and similarly I will press an enter over here as well. Let me just reduce this. So what do we have? Begin figure, then begin subfigure, enter, begin subfigure, enter, and then begin subfigure. Let's build and run to see what happens. Well, all images appear one below the other. They are definitely subfigures. We have A, B, and C, but they are appearing one below the other. And that is because of this enter sign, the enter key that we pressed. Enter key, or basically a blank line, actually denotes a paragraph in LaTeX. So this is a very common mistake, while coding, while writing subfigures in LaTeX. You shouldn't be adding an enter key to avoid this problem. So let's just remove it and build and run it again. So now we have 3 subfigures next to each other. All right. Let's go back to the slides. So we inserted an image, scaling and resizing was done. We rotated it, we cropped, we added borders, we displayed the list of figures, and we also displayed subfigures. Now let's proceed ahead. What is an index? Back index or an index usually contains a list of words and the page numbers on which they appear. It's usually used in a book or in a large document. We generally use it so that it becomes easy for the readers to refer to a particular word. Let's have a look at how to insert an index into our document. So I'll go to Text Studio and I will create another document. Let me save it as 2.tech and write /document class article /begin document, and let me just paste some random content from the internet. Okay, let's just paste multiple times so that we have multiple pages in our document. All right, let's build and run it. So we have around 3 pages worth of content. So this is good enough. Now to insert an index, we need to use a package called I-make-IDX. The package name is I-make-IDX. And then we need to tell LaTex to create an index. So the command is /make-index. And where we would like our index to get displayed, usually it is at the end of the document. So which is nothing but just before the end document command. So we would write /print-index. So 3 things. The package I-make-IDX, make index command to tell LaTex that we are interested in creating an index, and finally print index to tell LaTex where the index should actually appear into our document. Now we would insert the entries into our index. So let's say we want Arduino as an entry. So we would write /index followed by the entry. Now our entry is Arduino. Let's say we want another entry, say USB. So I'll insert another entry in the index by writing /index USB. Okay, let's just see what happens over here. Let's build and run it. I-make-idx.sty is not found. Yes, actually I had installed LaTex just recently, and I installed by mistake, instead of installing full LaTex, I just installed I-make-idx. Let me just divert a bit. I have the I-make-idx.sty. I'll just copy this and I'll just paste it in the folder where I'm actually demonstrating, which is here. So there are situations where you may face this kind of a problem. For example, a particular style file is not found. So when you do that, when you encounter this, one is the style, there's a mistake in spelling mistake in the style file, or the style file actually doesn't exist. Either you do not have a full LaTex, or it's a custom style file. So for that,